This is Akil, and this is Lukman, struggling to understand electron affinity.
I'm studying chemistry right now, and I'm stuck on electron affinity. Why are the values sometimes negative, but sometimes positive?
Okay, that is easy, bro. It's all about energy change. Look at the first slide. First electron affinity is usually negative because energy is released when an electron is added to a gaseous atom. This is an exothermic process.
Oh, so a more negative value means a higher affinity?
Okay, the more negative the value, the easier it is for the atom to gain the electron and becomes a stable anion.
But look at the second slide. Why does argon have a positive value?
Oh, I see. At the second slide, noble gas like argon already have a stable full valence shell. Adding an extra electron force into a new higher energy subshell, the 4s orbital. Acquiring a higher energy subshell is unfavorable. You have to absorb energy to make it happen, which result in a positive value. That makes the resulting anion less stable than the neutral atom.
Oh, so negative is equal to energy released because it's stable, and positive is equal to energy absorbed because it's unstable. I got it now.
Electron affinity was not discovered in just a day. So what does the expert say?
So now we're going to talk about the general trend of the electron affinity. So as we know, while going down the group, this increases, and thus the effective charge will decrease. And the electron affinity, which is also known as the EA, will also decrease to become less negative. While across the period, the size will decrease, and the effective charge will increase. And the EA will also increase to become more negative.
Let's look at group 17 in the periodic table. We all know that going down the group, the value of electron affinity decreases. But what's the reason? This is because going down the group, the size of atom increases. Thus, the electrostatic attraction between the electron and nucleus decreases, making it harder for the atom to accept electrons. So, in group 17, by gaining an electron, halogen atoms such as fluorine, chlorine, bromine, and iodine forms a stable negative ion that has a noble gas configuration.
Hi Anna, what are you doing?
Hi Nadia, I'm reading about the electron affinity of the periodic table.
You understand it quite well, I see.
Yes.
Yeah, explain it to me. It's a bit confused.
Okay, let me explain to you. Okay, so basically, we all know that across the period, the electron affinity will increase and become more negative. But there is some exceptions in group 2, which is the anomaly, because the value of the electron affinity must be more than 0, which is positive. These exceptions happen due to the valence electron configuration of group 2, because when the electron is added, the electron will reside to the empty p subshells, which is higher in energy, and is shielded by the ns2 electrons. Therefore, the value of electron affinity will be too big because the new opening of energy level.
Oh, what is the explanation?
So there are other cases that you need to know as well. So generally, when going down the group, the electron affinity will decrease. But in group 2, the electron affinity will increase going down the group and becomes more negative. This is because when going down the group, the atomic size will be bigger, right? So the outermost shells of the valence electron will be further from the nucleus. And the average distance of the electron added from the nucleus will increase, but the electron nucleus attraction will decrease. Okay. So hence, the electrons will be easier to add in the atom due to lower shielding effect.
Oh, I understand it very well right now. Thank you Aina for explaining it to me.
Anything for you. Welcome.
Group 5A actually has lower electron affinity than expected, and this is because Group 5A element already have a half-filled p subshell, which is considered a very stable electron arrangement already. For example, if you look at nitrogen, which have the electronic configuration of 2p3, where each of the 3p orbitals already contains one electron. And to visualize it further, we can use the Koch analogy. Each of the 3 already have their own space, so the arrangement is comfortable and stable. However, when another person tries to join in, there is no empty cushion left, so someone has to squeeze in with another person on the same spot. This craving and discomfort represents what we call electron-electron repulsion. And because of this repulsion, adding another electron requires more energy. Hence, group 5A elements does not gain electrons as easily as expected, which results in their lower electron affinity.